So have you seen what I have done? It is the modern periodic table. Group 1, Group 2, Group 13, Group 14, 15, 16, 17, 18. You may have doubt. Why have I left space in between and I have started 2 to 13? How is it even possible? Where are the rest? Yes, so the space I have left is for transition elements. So transition elements are from 3 to 12. So these transition elements you will not be studying now, you will be studying in your class 11. So for class 10, you don't need these transition elements. You don't need to study for class 10th and 9th. Now shall we fill the boxes? So I guess you all will be knowing the elements from 1 to 20. Shall we fill them? Yes. So it starts from hydrogen. Hydrogen. And your next element is helium, then lithium, then beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, magnesium, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. So only till this you are going to study in your 2 classes. I have forgotten to draw the box for potassium and calcium. Okay, now it is a very important class, you have to listen it. Okay, so have you seen how they have arranged? You may think they have arranged according to their atomic number. Okay, so for class 9th and 10th, for higher classes also, learning the atomic number from 1 to 20 is very important. Only with that you can survive in chemistry for class 9th and 10th. Now, what is the atomic number of hydrogen? It's 1. Okay. And what is electronic configuration of hydrogen? It's 1 itself. Now, helium. What is the atomic number of helium? It's 2. And how have we written in one period? Electronic configuration is also 2. Here comes a very important thing in your chapter. Helium, I have kept it in group 18 and hydrogen in group 1. Okay, let's forget about all those things. Let's first talk about hydrogen. Hydrogen, why I have placed it in group 1? Because its atomic number is 1. Its valence electron is 1. Now let's come to lithium. What is the atomic number of lithium? 3. 2, 1. What is the electronic configuration? 1. Sodium. What is atomic number? 11. 2, 8, 1. Potassium. Atomic number? 2, 8, 8, 1. It's 19. So, did you notice one thing? The valence electrons are very same, are similar for all the elements present in group 1. They have only 1 and then definitely their valence will also be 1. So that is the reason why they have been placed in group 1. Okay, are you able to understand what I am saying? The valence electrons will determine in which group the element is going to be placed. So since the valence electron of hydrogen, lithium, sodium and potassium is 1, they have been placed in group 1. Now, did you understand this part? Okay, now let's go to group 2. Who are the group 2 elements? Beryllium. I will be writing here, okay? Beryllium has 4. So 2, 2. Magnesium has 12. 2, 8, 2. And then calcium, I will write it here, has 20. 2, comma 8, comma 8, comma 2. Did you notice another most important thing? The elements present in group 2, their valence electrons are 2. So whichever elements are having their valence electron as 2, they will be placed in group 2. So your valence electrons determines the position, that is in which group it is. Now you may ask me, helium is also having 2, but then why it is not being placed? Because helium is a noble gas. So it has been, group 18 is for noble gas. So in group 18 only noble gases will be placed, not anything else. Group 1 have colors different, group 2 are different. Actually there are particular names for each group. I will be telling you this after this topic. Okay, so now next, group 13. Group 13, the elements are boron and aluminium. Wait, I'll write it here. I'll make this a circle. Group 2, group 1, and then where shall I write group 3 now? Okay, I'll write it here. Group 3. Group 3 elements are boron. What is the atomic weight of boron? It's 5. So 2, 5. And sorry, not atomic weight, atomic number. Aluminium, it's 13. 2, 8, 3. Okay. So the same thing, it carry forwards. Now you may have a small doubt because it's group 13, but the valence electron is 3. But how are they? Here you have to learn a very important thing. So for 1 and 2, when the valence electron is 1 and 2, you have to just leave it as 1 and 2. And you have to put them in group 1 and group 2. But for other valence electrons after 2, that is 3, 4, 5, 6, you have to add plus 10. So if I add plus 10, it becomes 13. So which group it goes? It goes to group number 13. So when it is 4 for carbon, which group? 14. Group number 14. Are you able to understand? Since transition elements are in the between, we take it in this manner. So after 2, whichever valence electron exhibits, we have to add plus 10 for them and place them according to their group. Okay. Now this goes on with everyone. Now you may have confusion with group number 18, neon. I'll clarify. So neon's atomic number is 10, 2 and 8 plus 10, 18. So the only part confusing is helium. Helium, you just remember, since noble gases have to come in one place, they have to assemble in one place, so we have placed it there. Okay. So now group part, is it easy for you? Did you people understand what is group, how the elements have been placed in each group? Group 1, hydrogen, lithium, sodium and potassium have been placed because their valence electrons are 1. Group 2, beryllium, magnesium and calcium have been placed because their valence electrons are 2. Group 13, boron and aluminium have been placed because their valence electrons are 3 and we have added plus 10. And we have placed them in group 13. This plus 10 you should not write in your exam. You have to just keep it in your mind and we have to place them. Okay. And next is periods. How are we placed them in periods? You may say they have in order we have placed. No, that's not the right way. Did you notice one thing? Hydrogen's electronic configuration is 1. So it holds one place. Next, lithium's electronic configuration is 2, 1. So how many numbers have there? 2. So since it has 2 numbers, it is being placed in period 2. And next, sodium. How many? 2, 8, 1. 3 numbers. So it is placed in period 3. Potassium 2, 8, 1. 2, 8, 8, 1. 4. So it is placed in period 4. Same thing holds on with boron. Boron, where is boron here? 2 and 3. 2 numbers, so it's placed in period 2. So it's the same for everyone. It's the same. So according to your electronic configuration, you can determine which element should be placed in which group and period. So electronic configuration and atomic number is a very important concept that each one of them should learn and should be very much thorough of that. because your electronic configuration determines which group and period the element should be placed. In exam they may ask you hydrogen and they may ask which period and group, and they may ask you argon, which period and group. Even for argon, what is the atomic number? It's 18. 2, 8, 8. It's 3. So it's placed in period 3. So same thing holds for all of them. Did you understand? Okay. And another important thing, if they ask you how many periods are there in modern periodic table, you will have to say there are 7. There are 7 periods. Remember this, you know how many days are there in a week? 7. And how many groups? 18 groups are there. 18 groups. Just remember this is very important. 18 groups. So your periods does not has any names, but your groups has names. Group 1 are called as alkyl metals. They are called as alkali metals, and your group 2 is called as alkaline earth metals, and group 3 to 12 are called as transition metals, transition elements, and your group 13 to 16 are called as post transition elements. Your group 17 is called as halogens, and group 18 is called as noble gases. So group 1 is called as alkaline metal because their valency is 1. Their valence electrons are also 1. And group 2, as usual, they are earth alkali metals. They are found in earth. They are alkyne and they are found in earth. And second, transition elements, and 13 to 16 they are post. That means they are after the transition elements. And 17 is called as halogen because their valence electrons are always 7. They always gain electrons. And they become halogens. They have valency as -1, and it's direct opposite to group 1 because group 1 donates 1 and their valency is +1. So group 1 and group 17 are opposites, and group 18, it is noble gases, non-reactive group. So the last concept that I am going to teach you in this chapter is electronegativity, number of shells and a nuclear atom. So first thing is electron negativity. Electron negativity in simple manner, if I have to tell you, gaining of electron. So if you gain more electrons, you become positive, you become negative. Like if you gain oxygen, its atomic number is 8, 2, 6. How many electrons it has to gain? 2. So -2. So it's more electronegative, right? So oxygen is electronegative, but hydrogen, lithium, sodium, they donate. So they are obviously not electronegative. So in this manner, we conclude that the elements which are on this side, that is, if I have to say, my right side are more electronegative than my left side. So from here to here, elements are very electronegative. Elements are very electronegative. And if I have to say from top to bottom, electron negativity decreases. So from here to here it increases, but from up to down it decreases. Which one? Electron negativity. Short form I have written En. So why? Fluorine's atomic number is 9, 2, 7. Chlorine's atomic number is 2, 8, 7. Since its shell, chlorine's shell increases, its electron negativity decreases. Number of shells increases, electron negativity also decreases. So top to bottom electron negativity decreases, electron negativity increases from left to right. From lithium, beryllium, boron to fluorine. Forget about this noble gases. Fluorine has the more electronegativity because it only accepts. But your lithium, it does not accept, it donates. So obviously it will have no electronegativity. And you may ask me, what about oxygen? It should have more, right? But why fluorine is having more? Oxygen is not having more because it is -2. So always -1 is greater than -2, right? So the same way, since fluorine is having -1, it has a greater electronegativity. Now number of shells. I guess you'll be knowing shells. What are shells? So 2, 8, 8. So these are called as shells. K shell, L shell, M shell. N shell, M shell, N shell, M shell. These are called as shells. So your number of shells decides your periods, your valence electron decides your group. This is very important concept. You have to remember this, okay? And your number of shells from top to bottom increases. So your number of shells, top to bottom, number of shells increases. So number of shells for hydrogen, how many? 1 shell, hydrogen. For lithium, how many? 2 shell. For sodium, 3 shell. So number of shells increases from top to bottom. But what about left to right? Left to right, number of shells remains same. So from left to right, number of shells remains same. I'll show you. Lithium atom 2, 1. Oxygen 8. 2, 6. Fluorine 9. 2, 9. Boron 4. 2, 3. So number of shells remains the same. So these are all the concepts that you have to remember, and your chapter ends here. So class 9th ICSE periodic table is done. So what are the concepts that you have to remember? Remember Dobenius triads, Newland's octaves, Mendeley's periodic table. What were the defects in Mendeley's periodic table? What were the contribution of Mendeley and Moseley's classification, basis of classification, periodicity of properties, the meaning of periodicity in elements, and then modern periodic table 1 to 20 elements you have to remember. Their atomic weights you have to remember. Sorry, not atomic weights, their atomic numbers you have to remember. The electronic configuration of each element from 1 to 20 you have to know, and groups and periods you have to know. How are the groups to be calculated according to their valence electrons? How are the periods according to their shells? And group 1 are alkaline metals, and group 2 are earth alkaline metals, and group 3 to 12 are transition metals, group 13 to 16 are post-transition metals, 17 are halogens, and group 18 are noble gases. So here ends your chapter 5 periodic table, class 9th ICSE. In my next class, I'll be taking class 10th periodic table ICSE. Okay then, bye bye. Have a nice day. I hope you enjoyed my video.